Hello everyone. This is Z Wong from the University of Tennessee. It's my honor to introduce my work learning fast converging, effective conditional generative adversarial networks with a mirrored auxiliary classifier. Generative adversarial networks have gained tremendous attention in recent years. In general, standard GANs are only capable of generating images that fall into random classes because the relation between the input latent variables and image labels is intractable. Therefore, the conditional GAN, which incorporates the label information, is designed for allowing the generated images to have a certain type. However, training conditional GANs are quite challenging. In this study, we propose an auxiliary classifier-based conditional GAN, namely, MAC-GAN, to generate high-quality images with label conditioning. Previously, AC-GAN is one of the most successful variants of conditional GANs. Besides predicting the image source, it introduces an extra classifier in the discriminator to predict class labels as well. When training AC-GAN's discriminator, both real and fake samples are fed into the neural network. However, there exist large gaps between the generator distribution and the target distribution. This issue makes AC-GAN difficult to train and converge. To mitigate this problem, FC-GAN proposes to introduce an extra fake class in the auxiliary classifier, and all generated images are categorized into this class rather than assigning them to a specific class label. However, the introduced fake class that handles all fake samples, which are usually with multimodal distributions, becomes a barrier that prevents the auxiliary classifier from getting converged well. To resolve the above issues, we propose a novel conditional GAN architecture with a mirrored auxiliary classifier, which in its discriminator contains both a real and a fake class for each category to distinguish real images from generated images that fall into the same category. With this design, the discriminator can converge fast and well. Our MAC-GAN consists of two loss terms, a source loss and a classification loss. Similarly as the standard GAN, for the source loss, the discriminator aims to distinguish real images from generated images. The generator is optimized to generate images that fool the discriminator. For a dataset with n classes, the auxiliary classifier in MAC-GAN represents a probability distribution over two n-class labels. Specifically, the classifier contains both a fake node and a real node for each class. For the classification loss, the discriminator is trained to assign each real sample to the correct real class and each generated sample to the correct fake class. On the other hand, the generator is trained to maximize the probability to assign each generated image to the correct real class rather than its corresponding fake class. In our study, we focus on the lightweight implementations of conditional GANs, which have benefits such as reductions of power consumption and fast inference. We implement a discriminator with 4 convolutional layers, followed by a fully connected layer. For the generator, we first sample the latent variable with a dimension of 100 from a uniform distribution and embed the label information with the latent variable. 2 dense layers are first implemented to extend the dimensions, and the output are reshaped into a 4-dimensional tensor, followed by 2 deconvolutional layers and a convolutional layer. We use 3 widely used benchmark datasets to evaluate the performance of MAC-GAN, namely MNIST, CFAR10, and ImageNet. We first present the generated images at different training stages with MAC-GAN and compare the images generated with AC-GAN and FC-GAN. It can be observed that MAC-GAN generate recognizable samples much earlier than AC-GAN. The samples generated by MAC-GAN present better visual fidelity compared with the other 2 models. Samples from MAC-GAN are clear and with substantial diversity, but those from the other 2 models are more or less blur, with artifacts. We also use 3 popular quantitative metrics to evaluate the image generation performance of MAC-GAN, namely, Parson window estimate, inception score, and Frechet inception distance score. From the experiment results, we can see that MAC-GAN outperforms AC-GAN and FC-GAN on all 3 metrics. These results validate the effectiveness of the proposed MAC-GAN architecture. In this study, we proposed MAC-GAN, which is a conditional GAN model with a newly designed auxiliary classifier. The classifier contains both a real and a fake class for each label to properly handle all the real and fake samples. By doing so, the generative model can get converged fast and well. Extensive experiment results and evaluations validated that MAC-GAN can achieve state-of-the-art image generation performance. Thank you for watching. Please refer to our paper for more details.